Dr. Werner Sobeck is a structural engineer and an architect. He's a specialist in the use of lightweight materials in buildings. Among the projects he was involved with was the KFW West Arcade, which is one of the award winners here at the 2011 Tall Building Awards, but we've got a lot of things to talk about. Welcome to Chicago.
Hello.
We'll start with the questions that we're asking of everyone on our kind of experts panel here. They've announced the 1-kilometer Kingdom Tower in Jeddah, Saudi Arabia, which is going to be the next world's tallest building if it's built. And what do you think is the single biggest limiting factor that would prevent us from actually putting up a mile-high building?
I think it's transportation. Transportation and eventually some social effects. That strongly depends whether you are going to build up a mixed-use building with a lot of social meeting areas, supermarkets, restaurants, and whatever, so that they have living and working together, and that many people do not have to leave the building in the morning hours and come back in the evening hours. If this would be the case, if it is a vertical city, then I think the only limiting factor is the transportation.
That's one of the things that we really haven't talked about when we've mentioned tall buildings, and that is the social aspect of them. Is what kind of things do you think about when you see a building like the Burj Khalifa go up, or some of these high-rises in new cities where there really have been none before? What are the social impacts that go through your mind as you see those?
I think as great as those buildings are and as great as the achievements are which came with those buildings, especially Burj Khalifa and other ones, when I think about building technology, overall architectural appearance, and so on, structural systems, the question of how to make or how to turn the addition of slabs and apartments into something which is a three-dimensional configuration of social contacts is not really solved yet. This is not that simple, I know, and many architects are working on it since many years, but we did not achieve what we should and what we could achieve. So I think this is really the demanding thing for the next year to come up with, that we try to combine working and living, the elderly and the young ones, the handicapped and the whatever, the fit ones, yeah, into spatial configurations in those super tall city buildings.
Has any building that's been designed and built here in the last 10 years, some of the new generation of buildings even started to approach that?
Not strong enough, not powerful enough. I know there are many restrictions, like whatever, building codes, and there's also a financial restriction and other things, but I think, in my opinion, I was not satisfied with this aspect with the buildings which came up. Not really.
One of the other questions was about this being the 10th anniversary of 9/11 and what we've learned in the last 10 years, and I don't know if a building can ever be safe from terrorism, but how much safer are we now than we were 10 years ago?
You might have heard that I have a very strong, very profiled and very different opinion on design against terrorism. But still, to be polite, to say it the following way: the buildings became safer for whatever might happen. It might even be a normal fire. The escape ways are much more clever now and much more safe than they have been before. To take the keyword terrorism, in total, I think the war against terror is nothing else than a great business idea. Nothing else. This is squeezing money and putting fear on people. Because there is no building in the world, and there will never be any building in the world, which cannot be brought down by someone who is a very well-educated engineer. So the problem is not making the building safe against whatever, because there is never any 100% safety against a combination of an engineer and a terrorist. The problem is to overcome terrorism, but by other means, but not by making the building's columns fatter and fatter.
The best tall buildings in the world today, other than ones that you have been involved with, what is the example, your best example out there of the best tall building?
There's a clear answer. This is the John Hancock building. The John Hancock Center here in Chicago at Delaware Place By the way, a building I'm living in since 12 years. I'm absolutely convinced that this old lady, as I might call it, it's now 40 years old. It's still in very good shape. It's still rather elegant, perfect building. And it came up with so many innovations at the same time. It was the first multi-use building. It was the first diagonalized tube. It was the first one to install in a height of 44 floors, supermarkets, restaurants, and whatever. I consider this building still as a shining example for everything which actually under design. And there's that much going up, actually, and we already heard about it in the symposium, where you ask yourself the question once you heard the presentation and you lean back, why is it this way? And many buildings, let's say, have a glance with something which is questionable and which turns into decorative elements, which are not true after 10 or 20 years. But if you look at the Hancock, this is a building without any decorative addition, and this gives the building its strength, which is still valid after that long period of time and which will be valid even in the next 100 years. It is a highly efficient building, it is minimized, it's carefully detailed, and it works perfect.
One of the buildings that really struck me in this year's competition, and you served on the jury for this year's awards, was the Index in Dubai. And one of the first things that came to mind was the John Hancock Center, just because this is also a mixed-use building that was kind of stacked in a similar fashion with office floors below and residential above. And that's also roughly the same height as the John Hancock Center, but of course the technology is much different now. Did that enter your mind too? When you saw that building, what strikes your mind as being the difference between the Index and the Hancock?
I think in the Index, the technology is much further advanced now. In the meantime, of course, the principle, the engineering and the structural principles remain somehow the same. The clarity of the structural layout and how it has been treated is very much comparable. But the Hancock was the first and the strongest one of its kind in the 70s, in the late 60s and early 70s. And this is what's still striking me. This, and a building of that typology in these times was really something where you had to convince everyone. This was a never seen before thing. Yeah? Now many other things, many other buildings coming up now take profit of this development because, of course, but what I'm sometimes missing is the big step forward, which was a never seen before thing, which is besides decorative additions. Yeah. And there are questions we have to solve. There are answers we have to give on questions the students pose. For example, the question of minimizing embodied energy, minimizing operational energy, making tall buildings absolutely green, making them socially, perfectionally functioning, etc., etc. And there is a lot of work which still has to be done by the professionals like us.
I'm going to read from an article that you were interviewed for in Dwell magazine that talks about building materials. And we've heard about them before. I don't know if it's in science fiction or what it would be, but I'm wondering how much closer these are. And the article says that modern advances in materials technology and manufacturing processes have opened up possibilities for entirely new kinds of buildings where, for example, a textile roof soaks up energy during the day and releases it at night, which we're already starting to see. A glass house embedded with electrified liquid crystals grows opaque on demand, or a facade breathes without the need for windows. And in the future, buildings will assume any shape you want, exert complete control over things like light, airflow, heating, and humidity, and do it all so efficiently you might never have to pay a heating bill again. What percent are we there? Because some of these things are familiar now where they weren't so familiar 20 or 30 years ago. How far?
Right, the development is quite rapid in the meantime, quite fast. And let's say the scientific research work on, for example, textiles, which are able to harvest energy, to store it and to release it later on after a certain period of time on command, let's say it this way, is quite advanced. This is nothing which you can buy and build into your house, your apartment, the next afternoon, but the things are under development, and as far as I see it as a scientist, there's a very positive and near end to that development. And I would say with the textiles, we are there in 5 or 6 years. With the switchable glass, we are actually doing research on one system where we also hold a patent since 10 years. We did this very extensively on small panes. So they're absolutely temperature resistant. They work perfect in the meantime. Now the only step which has to be done is extend that laboratory size to the real size found on site. It means floor to floor high elements. And this is what we are actually developing together with the industry. There might be another 3 to 4 years and those things are on the market then. They are not that expensive. This is the surprising factor too. Means actually if you have a sunshade system plus an insulated glazing, in the future you can forget about the sunshade system. You have it integrated in the switchable glass and the total sum per square foot is lower as a cost to buy it than before with the 2 separate systems. Not to talk about maintenance, cleaning and other things. There is another interesting development which is driven by the institute I'm heading in Germany. We call that graded concrete, which is the first time ever that we have what we call an interior optimization, an internal optimization of concrete. Means any concrete structure, of course, you put the steel there where the tension is, but the concrete is everywhere, even where it is not needed. So what we do is we make porous concrete where we have pores of different size and intensity everywhere there where there is no stress. And this enables us, for example, and we already tested it, to reduce the dead weight of typical floor slabs by 40%. Now 40% is quite a number. If you take a high-rise building made out of concrete with a height of maybe 200 meters, the total structural dead weight is 160,000 metric tons. And if you save 40%, then this is already the 60,000 of it. So this is something, not only if we talk about resources and transportation, we also talk about embodied energy and a reduced recycling problem. And of course, gradient or graded concrete, as we call it, is something which has another, let's say, technological level. You can't do that with uneducated workers. So it's very much automated, but you can pour the concrete day and night in a continuous process and create something which is far ahead of what we can imagine nowadays and what we could dream about yesterday. So there are several things on their way, and the market of the need, let's put it that way, the need to come up finally after sleeping for several decades with more sustainable buildings is driving those developments. Building industry totally overslept that development. There was also no political pressure. But I just remember, look to Europe on how the governments have pushed the car industry to reduce the consumption of gas. In former time, a high-end car was consuming 20 to 30 liters per 100 kilometer. Nowadays, you can buy the finest cars which just consume 5 or 6. Recyclability ratio in German cars is actually 85% by law. If you ask a contractor about his recyclability ratio on the buildings he's doing, he wouldn't have an answer. But the built environment is the largest anthropogenic storage ever. And this is a responsibility we have as architects, engineers, contractors, and so on, that we have to take care of the materials we put or we build into this anthropogenic storage. Because if we do it in a way that the materials are not recyclable or in the sense of cradle to cradle reusable, then we might run into a shortage. And shortages, as we all know, cause social problems.
Is that the greatest advantage of slimming down buildings? Because this article also talks about how much does your building weigh, and your call for radical engineering to slim down today's structures. Is that part of the economic return on that, which is that you're not using as much material in the building and you have it to use elsewhere?
For me, this is a moral standpoint, just a moral standpoint, because this is facing the upcoming generations, and they will ask the questions, what did you do with our copper, with our steel, with our oil? The question, see, the situation is such that, and you might discuss this plus minus 10 or 20%, is, I do not care, that since the industrial production of petroleum started to now, this is just 100 years. And in 100 years, the average population on globe was 1 billion or less. Now, 2010, 2020, we have used 50% of the existing petroleum. That means if 1 billion uses in 100 years half of the existing petroleum, then 6 or 7 billions will use the rest in the next 20 years. We know about that. We don't talk about it because we don't have an answer what to do. But it's quite evident that we will run into brutal social and political problems. Not war against terrorists, but war for oil. And now we, in the building industry, being responsible for more than 1/3 of the energy consumption, we have to face that problem and we have to do something against it. And this is not only reducing heating and cooling loads during the operational phase. It is also reducing the amount of material we use to do the buildings and cutting down the embodied energy. Actually, a Central European residential buildings, let's say a single-family house, built in the 80s or 90s, with quite a fine insulation and so on, standard, has an embodied energy, which is the equivalent to 30 to 40 years of running the building and its energy consumption there. So how much sense does it make to drive down the consumption of energy during the operational phase by another 5 to 10% in comparison to this huge amount of energy which you use to erect the building? And being, with my other jacket, a structural engineer, I can clearly judge how much material is wasted all over the world because of non-proper engineering. Yeah? You might do an engineering like this, you put the column that size, you know it always works. If you do an iterative process, driving down the size, this costs you time and fee, but you save a lot of money. And this is what needs to be done. So the honesty of engineering in this field of being more careful with the consummation of materials and being more careful with developing clever structural system is something we have to finger point much more than we did in the last decades, much more.
What, listening to you talk and recalling some of what I've seen in the last 10 or 15 years when I'm visiting architecture firms and I see building models, I think of one trip I made here in Chicago in the mid-1990s and saw what at the time looked like very cutting-edge future, kind of outlandish crystalline shapes and diagrid support systems that looked like fantasy, and that now we're seeing these buildings rise. And when I listen to you talk about materials and glass, you know, it took 15 years for those ideas to become reality. What features are going to start showing up on some of these building designs in the next 5 years that we'll see 15 years from now in actual design models?
I think there are two things. The one is focusing on a higher comfort level inside, a better fresh air supply, a reduced energy consumption to cool or to heat this air, but a better air supply with a better, let's say, natural light supply and better acoustic conditions is the one thing we are heading for and where we put a lot of research work in. And you can easily show that, for example, the productivity of the people or the rate of illness and all those things are turning into the better direction if you take more care for this. There was this term thick building syndrome. Of course, this is already 20 to 30 years old, and a lot has been done, but not on the level of the principles, central air supply or decentralized air supply. Minimized energy consumption, for example, with decentralized air supply, or just pumping the energy out of the window. So it's a big field. It's the combination between energy saving and comfort, illness or health, productivity, feeling. This is the one thing, and the other is, what I'm very much convinced of, is the recyclability. Nobody wants to hear that, because it is a term which, let's say, doesn't sound too attractive, at least not elegant or not reaching out high. But facing the fact that we are running into a copper shortage, that we are running into shortages with rare minerals and all those things, that the waste dump costs are so high in the meantime that if you would ask the clients to pay the real cost, nobody could tear the building down. So this is all subsidized and subsidized by the governments, at least in Europe. These are issues which will become more and more important. So it's the recyclability, the reduction of the amount of material used, the comfort and health, and the operational energy thing, and the developments I already talked about, which enabled us, like graded concrete, for example, or clever, how you call that, let's say, for the single living unit, clever automation systems means not a central automation where the temperature and the air humidity and so on is governed by a technician somewhere, but where the people themselves can tell to a system in a very simple way, even by spoken words, I'm leaving now, you might reduce the temperature, and I will come back at 6 o'clock and I expect comfort levels again, and then walk away. And the system does it. Such systems, by the way, are actually not only under development, they are developed and they are actually in the testing phase in Germany.
You alluded earlier to the role of the structural engineer in bringing these ideas of efficiency about, and how on KfW West Arcade that you had to work with the building owner and with the architect to really bring these things about. What's that process like? What was the collaboration on that project?
What is the absolute must for such an outcome, for such a result, is a very close cooperation from the very first second on between the architect, the structural engineer, the people from the facade technology, and the energy specialists, and of course the client. If the one goes ahead in a so-called sequential planning, you will never achieve an optimum. You have to do what we call an integrated planning, but this also necessitates that the people, the parties sitting around the table are able to talk to the other ones. When I look at nowadays universities and when I realize, everyone knows that the people from the engineering department never talk to the ones from the architectural department, never talk to the ones from the HVAC department. Students think, okay, an architect is probably something different as a human being than I am as a structural engineer, and so on. And this is the fault of the professors. The students are educated with other, let's say, ways to think, with other goals and targets, which turn after 5 to 6 years education also into another language. And now you have a Babylonic effect once they leave university and meet first time around the big table. Because if the architect says, I intend to create something warm, the engineer says how many degrees Celsius or Fahrenheit. But this is something he never meant. Yeah? This is a very trivial example to make clear what I intend to express. So overcoming this, let's say, this separation and the evolvement of different languages and targets and goals, which is caused by the education we have nowadays, is very, very important. And I tell my students all the time, take some time and see the philosophers, and take some time and spend 100 or 200 hours a year in the architectural department. Look what they are doing, visit their exhibition, talk to the people there. This is the only way how to learn and how to understand how they think and how they function and what their goals are, their intentions are. And the same, of course, should be true for architectural students and other ones. I always say it is still called university and not monoversity. Yeah? University means reaching out for diversity and for a whole picture of the world, and not for a specialized small track fast time education, which is so fashionable nowadays. And this is the need. And this is also, if you talk about markets, a certain advantage. We would have been never that successful as we are if I wouldn't have studied car body design, aircraft design, architectural and structural engineering at the same time. Of course, it took me 3 semesters longer than my colleagues. But the overview, the oversight I got onto all the topics was so much better then. And I'm profiting from that still. So weaving in our actual facades, technologies I learned to know 20 years ago while visiting Boeing or Airbus is a self-understanding thing because I have that somewhere in the storage. And when the problem pops up, I know about the solution. And the same is true with textile or car body design and so on and so on. And this is what we need, a wider education, a wider scope in the education. And this is then the basis for a cooperation like the one with Louisa Hutton and Matthias Sauerbruch for the KfW, where we did the structural engineering for the primary structure as well as the facade technology. And primary structure, of course, has been minimized in the member sizes down to what's doable. And the facade technology, I think this is a very fine piece of the art of how to do a facade nowadays. It's all unitized, prefabricated with low tolerances. And of course, then the concrete structure has to meet those low tolerances too. But it worked out fine.
Do you have any general comments, because you were on the jury for this year's awards, just of the quality and the type of the projects that we're seeing? It sure is a diverse lot, and there's a lot of sustainability involved.
I'm lucky to see that the sustainability aspect, as I already mentioned, becomes more and more important. And under this aspect, I think we got good achievements. The buildings are really outstanding. They are shining examples for the state of architecture and the art of engineering nowadays, this year in 2011. And being an example, I hope that they provoke further development in the fields we talk about.
Dr. Werner Sobek, thanks for coming by to see us.
Thank you.